Okay, hopefully the background noise isn't too much. Just have a pellet stove running. Okay, so for day two, we're going to talk first about coterminal angles, and then the next important topic is going to be reference angles. And those are the two big ideas for this section. Okay, so coterminal angles are going to be two angles in standard position where the terminal sides line up with each other. Okay, so if I was going to draw an angle in standard position over here, and we'll call this angle theta, another angle that would be coterminal with it would be, I'll do it in a different color so you can see it, line is up exactly the same way, but maybe you got there a different way. So you went in the opposite direction, or even you went around more than one time to get there. Okay, and those would be coterminal angles. Okay, so let me get rid of some of these arrows here. See if I can get rid of the red. Yes, can I get rid of this red? And I got rid of the blue. That's okay. Okay, so an example would be, let's suppose this theta angle here is 120 degrees, and I wanted another angle that was coterminal with it. Well, there's a bunch of ways that you could do it. You could take the angle theta, let me erase that. You could take that 120 degrees and just add 360 to it, and you would get another angle that was coterminal with it. In this case, it would be 480 degrees. You could also take the 120 degree angle and subtract 360 from it, and that would be negative 240 degrees, and that would be coterminal. And you can get an infinite number of coterminal angles by just basically keep adding and subtracting 360 from the angle. All right, so if theta is a degree measure, then the angle measures of theta plus 360k, and I'll talk about what that k means. Or if it's a radian measure, theta plus 2 pi k, where k is an integer, and I'll talk about what that means in a second, will give you every single coterminal angle with angle theta. Okay. So let's suppose theta is a degree measure for an angle. Well, if I did theta plus 360, I would get another coterminal angle. If I did theta plus 360 times 2, meaning went around twice, I'd get another coterminal angle. If I did theta plus 360 times 3, I'd get another one. If I did theta plus 360 times negative 1, I'd get a coterminal angle. Theta plus 360 times negative 2, I'd get another coterminal angle. Put a 1 right there. So if I want every single one of them, I'd do theta plus 360 times k, where k stands for any integer I want to put in for that value right there. So this gives you all of the coterminal angles. If you wanted to do it in radians, theta is a radian. I'm not going to do the whole same exact thing, but all you do is do theta plus 2 pi, because it's in radians, times k, and that would give you every single one of them. Okay? All right, so let's go down here, and we're going to come up with one positive, one negative, and all of the coterminal angles. Okay? I'm not going to do every single one of these. It's a little bit redundant. So if I did 45 degrees, I would do 45 plus 360, and that would be, what is that, 405? 405 degrees would be coterminal. If I did 45 minus 360, which is 315 degrees, negative 315 degrees, I'd get a coterminal angle. If I want all of them, 45 plus 360 times k. Okay, and that gets you all of them. One thing I do want to mention, I'll kind of go back up here to do it. This theta plus 2 pi k, some textbooks do theta plus 2 pi. They use n instead of k. It's interchangeable. I don't care which one you use. I'm pretty sure next year in calculus, the The textbook uses N, but the AP exam uses K. So it means the same thing, and I really don't care which letter you use. Okay, let me do a radian one here. We'll do 11 pi over 5. So all you're going to do is 11 pi over 5 plus 2 pi. We have to do a little simplification, which is 11 pi over 5 plus, change that into 5, which is a 10 pi over 5. So 21 pi over 5 would be our positive one. And then we'll do 11. Now you see what's going to happen here. If I do 11 pi over 5 minus 10 pi over 5, I'm still going to have a positive angle. Now, you could, if you wanted to, subtract that and get pi over 5 and use that as your positive one. I'm okay with that. But if you wanted to jump right into, you could just subtract 4 pi from it. Just go around twice. So if it was 4 pi, this would be 20 pi over 5, because 20 pi over 5 is equivalent to 4 pi. And you're going to get negative 9 pi over 5. You could also just take this line right here and go, well, let me just take pi over 5 and subtract 2 pi from it, 10 pi over 5. And you'd also get negative 9 pi over 5. All right. Either way, it does not matter. Okay. Yeah. So sometimes you have to subtract 2 pi twice, and you're always subtracting 2 pi. So you could subtract 2 pi, you could subtract 4 pi, you could subtract 6 pi, it doesn't matter. Okay. So there's your coterminal angles. Okay. Now we're going to determine, and this is a really important skill, to figure out what quadrant you're in. Okay. Now, some of these you should absolutely positively know where you are, and others you have to, do a little work. So 7 pi over 4. Now, you could know that that is in the fourth quadrant just by, because that's one of the ones we have to memorize. Or you could just realize that right here is 8 pi over 4, right? Because that's equivalent to 2 pi. And that's just shy of it, so I'm in the fourth quadrant. If you need to give yourself a little visual of drawing that graph, then go ahead and do it. Okay. 210 degrees negative. I do the positive version of that. So positive 210 would be in this quadrant. The negative version is always right above it or below it, depending on which quadrant you're in. So this is going to be the second quadrant. All right, now 7 pi over 12. I think the easiest way to do this is to go like this. If it's not one that we have to memorize, you put them in terms of twelfths. Right there is 0. Right here would be 12 pi over 12, right? Because that's equivalent to pi, if you simplify it. Well, halfway in between 0 and 12 is 6 pi over 12. Well, 7 pi over 12 is just a little bit more than that, so I'm right here in the second quadrant again. Okay? 430, all I do for anything that's greater than 360, I just subtract 360 from it, 360 from it, to get an angle that I know is in between 0 and 360, which is 70 degrees. So 70 degrees, that would be in the first quadrant, right? Because 430 and 70 are coterminal angles. All right. 3.3 radians. Hold on one second. 3.3 radians, there's a little R there that stands for radians. So remember, you have to memorize these. Right here is 1.57 approximately radians. Here is 3.14 approximately. Here is 4.71. Here is 6.28. So obviously 3.3 is a little bit greater than pi. So it's there. So that would be in our third quadrant. Okay, I'm not going to continue doing every single one of these. You get the idea. For this one, just keep adding 360 until you get something that's in between 0 and 360, or 0 and negative 360. Same thing for this one. Now, for this one, this is kind of helpful to know if you want to know this. Like right there is 0, 180, 360, 540. Back over to here is 720. Back over to here, let's see if I add 180 to that. 180 to that. 0, 0, 9, I believe. Yep. And then if I'm back over to here, I get adding 180 to that would be a 1080. adding 180 to that. And you can keep going back and forth, but one of the angles that ends up over here is 1440 is right there. So 1430 is just shy of that. So you'd be in the fourth quadrant for this one. What I would do for, I am going to do this last one here. What I would do for negative 19 pi over 3, you can do one of two things. You can make them over 3, so that's 0. Now this gets a little bit involved because you're going to have to go quite a bit of ways around. 6 pi over 3. This right here, I don't know if I mentioned this. I think I did, but right here is 0 pi, 2 pi, 4 pi, 6 pi, and so forth. All the even pi's are over here, and all the odd pi's are over here. 1 pi, 3 pi, 5 pi. When I say, I meant right there. So if you want to get another one, so that's 1. If I want to get 3 and I want to put it over 3, I put 9 pi over 3. If I wanted it over 3, but I wanted it to be 4, that would be 12 pi over 3. If I wanted this to be 5, that would be 15 pi over 3. And over here, if I wanted it to be 6, I'd have 18 pi over 3. So positive 19 pi over 3 would be in the first quadrant. So the negative version of it would be right below it. So it'd be in the fourth quadrant. You could, and again, that might be the long way. And again, I'm just showing you different ways to do it. You pick what works for you. You can also do this. Some people do this, and it's not a bad idea. Go back to like elementary school, and you change this into a mixed number, which is 6 1/3 pi. So really what you're doing is a 6 pi plus a 1/3 pi. Well, 6 pi is right there. Pi over 3, which is really that, is a little bit more, and then the negative version's right below it. So it doesn't matter which way you do it. Okay. Reference angles. Now, again, another really important concept, reference angles. This is going to help us with some of the harder stuff that comes up later. When we're doing like, what's the sine of 120 degrees, or what's the cosine of 315 degrees, or what's the tangent of 225. If you know an angle's reference angle, you'll be able to easily get these answers. And just to, kind of show you ahead a little bit, the reference angle for that one is 60 degrees. You might know why. The reference angle for this one's 45 degrees, and the reference angle for that one is 45 degrees. So really what you're just doing is the sine of 60, the cosine of 45, and the tangent of 45, which you may already know what they are. Well, you learned it, but you might not remember it. Okay, so that's kind of why this is important and why we're doing what we're doing here. So, all right. So a couple of things with a reference angle. It has to be acute. Now, this definition isn't great. It's a little bit redundant. It says it has to be an acute angle between 0 and 90 degrees. Well, between 0 and 90 degrees by definition is acute. But I think what they're doing here is saying that if it's in between 0 and 90 degrees, it has to be a positive acute angle. And remember, it's always positive. And then it's formed by the terminal side of an angle and the x-axis. It is never the y-axis. Never, ever, 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 ever. Okay, so here, let me just give you a little picture here. So if I was going to draw an angle here in standard position, again, I'll put it in the second quadrant. Here's angle theta. Its reference angle is that angle right there. There is the reference angle. For theta. Okay, because it is formed by, get a different color here, the terminal side, so there's the terminal side, it's terrible tracing, and the x-axis, so it's that angle right there, okay? All right, so here's how you figure out the measure of reference angles depending on what quadrant it's in. All right, so let's sketch a angle in standard position in the first quadrant. There it is, we'll call it theta. Well, the reference angle for an angle in the first quadrant is the angle itself, right? So this I'm going to use RA for reference angle, is actually theta. Okay, so first quadrant's pretty easy. Second quadrant, it's so difficult to draw in this Chromebook. Draw straight. Here's theta. Here's the reference angle. How do you figure out its measure? So the reference angle there is going to be 180 degrees minus theta, or if it's in radians, pi minus theta. Okay, depending on the questions in degrees or radians, how you answer that. Okay, so think of it this way, like if this is 180 degrees and let's suppose this angle is 120 degrees, then the reference angle is the difference in between those, right? So the way that you figured out is 180 minus 120. Okay, next. Third quadrant. Here is theta. Reference angle is this angle right there. Okay, this is the one that people always want to try to make that the reference angle. Don't do that. It's always the x-axis, not the y-axis. Okay, so the way that you figure out this reference angle is you're going to do theta minus 180, or theta minus pi, right? Because if this was 240 degrees and this was 180 degrees, the difference between those is 240 minus 180. Okay, and then the last one, try that color. Fourth quadrant, here's theta. So here's the reference angle, right there's the reference angle. So the reference angle for this one is going to be equal to 360 minus theta, or 2 pi minus theta. Okay, so that's how you figure out all reference angles. All right, let's go through and find the reference angle for each of these. Now, I don't care if you show work for these or not. Some people just know them. Some people have to show work. So obviously this one here is going to have a reference angle of 15 degrees. If you need to show work, it's up to you. You just kind of do one of these and go, hey, let me sketch an angle in standard position that represents 195 degrees. There's 180. There's the reference angle. The difference between them is 15 degrees. Okay. Negative 290. Now, I would probably draw this one out. So positive 290 would be down in the fourth quadrant, the terminal side. The negative version would be up here. So there is negative 290 degrees. Well, there is negative 360 degrees. There's the reference angle. Now remember, it's positive. It's always positive. So that would be a 70-degree reference angle. All right, now the nice thing about radians, and this is where it's like, you're learning degrees to radians and maybe across your mind, it's like, okay, what's the big deal with radians? Why does it matter? This is one of the reasons why it's nice. If you have a reference angle that's one of the angles that we're going to have memorized, that's in the 30-degree family, 60-degree family, or 45, the reference angle is the family. So if I'm looking through these problems, number 3, number 6, number 8, number 10, and number 11, I can just go through and go, no thinking involved. Pi over 3, because that's what family it's in, the 60-degree family. This one, pi over 3, because that's what family it's in. This one, don't worry about the negative. It doesn't matter. It's pi over 6, because that's what family it's in. 301 pi over 4, don't think, it's pi over 4. I always have people on tests trying to figure out, like, gee, I wonder where this is if I keep going around and around and around. You don't need to. Okay, now this one you just have to be careful with a little bit because you can simplify it. So you always want to check out. Typically, they don't make you simplify it. I do it just because I want to keep you, keep you aware. All right, so I'm going to divide these both by 3. So you get 5 pi over 2. And now you're like, oh, okay, well, 5 pi over 2. 4 pi over 2 is right there. 5 pi over 2 is right there. So it's a quadrantal, right? There is no reference angle for this. And the reason why there's no reference angle, because that angle is 90 degrees. And by definition, it has to be between 0 and 90, all right? All right, so let's go back and do some of these other ones. So the reference angle for 8 pi over 5, this is what I would do. This is definitely one I would draw out. I'd put 0 there. I'd put 5 pi over 5 here. If I went back around, this would be 10 pi over 5. Now you have to be careful. Now this one's a little bit obvious. 8 pi over 5 is closer to 10 pi over 5 than it is to 5 pi over 5. And I just say, okay, it's closer. How far away is it? 2 pi over 5, and that's its reference angle. You just have to be careful that whatever angle you're talking about, does it cross over this y-axis on either side? So you're basically looking on what side of the y-axis is it, and then that'll tell you its reference angle. If you don't check, you're going to get them wrong. For this one, just subtract 360. So if you did 550 minus 360, that's a 0, 4, 1, 10, 9, 190. Its reference angle is 10 degrees. Degrees are pretty simple. All right, 30 pi over 17. And again, what I would do with this is I would just make these 17ths. This right here, if you went twice around and it's over 17, 17 times 2 is 34 pi. Now, 30 pi over 17 is closer to 34 than it is to 17. So its reference angle is the difference between it, 4 pi over 17. Okay? All right, so that's pretty much all we have to do. If you need more practice changing degrees to radians, go ahead and practice these, okay? And for 9th period, this will be your homework for Thursday evening, okay? All right, done.